Right. So the third graph, I means already we discussed this speed time graph. Here, speed time graph, we have three cases. One is speed at constant, then other one is speed changes uniform rate. If speed changes, means the change in speed is increasing, well, if increasing velocity, if the slope is straight upward straight line, positive acceleration, the slope is downward straight line is negative acceleration or retardation or deceleration. The slope is given idea about acceleration. The area, the area of this right angle or this right angle, right triangle, right angle triangle, right angle triangle, about distance traveled, distance traveled, right? Then as I already told you, we can draw, we can explain the motion of the body by drawing graphs. The second one, in a speed time graph, speed time graph, three cases there are. One is if the speed is constant, if speed changes at a uniform rate. Increasing speed at a uniform rate, we get upward straight line. Change in velocity or change in speed is decreasing, we get downward straight line. Upward straight line is give positive acceleration, downward straight line gives us a negative acceleration. Then coming to the third case, coming to the third case, speed time graph, when the initial speed of the body not equal to 0. In those examples, in these graphs, initial velocity of the body equal to 0. Initial velocity of the body equal to 0. Then a third case, speed time graph. Speed time graph if initial velocity is not equal to 0, is not equal to 0, is not 0. Such cases, the distance traveled by the body. So if we draw the graph, here the initial velocity O, here the object is started, we get like this. Then if we draw one perpendicular to a time axis, here time, here speed. When we draw the distance or speed time graph for a body whose initial velocity not 0, whose initial velocity not 0. So that this graph represents, or the time speed time graph represents, if the body having an initial speed equal to OB, then accelerating from B to C. B to C. Here B, C. At B, in the sense the initial velocity not equal to 0. We are taking some from other point. In order to calculate the average, in order to calculate the acceleration graph, from the graph, we have subtract the initial speed from the final speed. Initial speed OB. Initial speed OB. Final speed is equal to AC. Here it is the initial speed. Then to know the final speed or the velocity, we need to find one point at a slope, AC. So acceleration, we know final velocity minus initial velocity. Final velocity minus initial velocity by time. That is equal to final velocity AC, initial velocity OB, time OA. Time OA. Right? Then we can calculate the acceleration. We can calculate the acceleration. So keep in mind, velocity time graph or times or speed time graph gives us idea to know acceleration. To know acceleration. If the speed is constant, no acceleration. If the speed changes with uniform rate, if increasing speed, positive acceleration. If decreasing rate of velocity or decreasing rate of speed, negative acceleration. Here, speed, initial speed not equal to 0. That's why we have to take the difference between final velocity and initial velocity with respect to the time. In those cases, what will happen? The slope represents directly acceleration. Is it positive acceleration or negative acceleration? So, AC by OC, AC by OC is the acceleration. In this case also OB by OA, OB by OA represent acceleration. Here no acceleration because of speed is constant. But here what will happen? There will be some initial velocity and there will be some final velocity. So acceleration is equal to final velocity minus initial velocity by time. According to a diagram, final velocity equal to AC, initial velocity equal to OB, and the time is OA. Then calculate distance traveled. Distance traveled. We know the formula speed into time. Speed into time. Speed into time. So when we observe the diagram, it gives us a quadrilateral, we can call the trapezium. We can call the trapezium. So here the area of the trapezium, the area of the trapezium gives us how much distance travel the body. How much distance travel the body. Distance traveled by the body in a given time is equal to the area between time graph and the time axis. Time graph and time axis. So this is gives us how much distance traveled by a body. It looks like a trapezium. So distance traveled by a body is equal to area of trapezium, area of trapezium OBCA, RAOACB. So we know the area of trapezium is sum of two parallel sides into height by 2 is equal to sum of two parallel sides into height by 2. Height by 2. Here the two parallel sides is OB and AC. OB and AC. OB and AC is the two parallel sides. That is equal to OB plus AC into what about the height? What about the height? Height is OA. Here OA is the height. OA by 2. This equal to distance traveled by the object. Even if the initial velocity of the body not equal to 0, not equal to 0, not equal to 0, right? So even speed changes with the uniform rate. Two cases are there. One is, so three cases. One is increasing, one is decreasing if initial velocity is not equal to 0. If initial velocity equal to 0, the change in the rate of velocity is positive. Then if the initial velocity equal to 0, then change in the rate of velocity is decreasing. If initial velocity is not equal to 0, then acceleration. Then finally, if the speed time graph, if the speed changes not uniformly, if the speed changes not uniformly. So here, this is the case 1, this is case 2, and this is case 3. Means speed changes with uniform rate. Speed changes with uniform rate. So here the case 1, if the rate is increasing or change in velocity increases, if the change in velocity increases, if the change in velocity, change in velocity decreases, then here, if initial velocity not equal to 0, but change in velocity is uniform. If the change in velocity is uniform. These are the three cases in second one. The third one, speed time graph. Speed time graph at change in speed, change in speed is non-uniform. Change in speed is non-uniform. If uniform rate, non-uniform rate. If the uniform rate, if it is increasing, this case. If it is decreasing, this case. If initial velocity not 0, that case. If change in speed is non-uniform rate, when we draw the graph between time and speed, time and speed, we get a curved line. We get curved line. We get a curved line. Slope, non-uniform acceleration. Non-uniform acceleration. Here observed that first one, if speed is constant, we get a slope as a straight line which is parallel to the time axis. If change in the speed is uniform rate, in case of uniform rate, again we have three types, three cases. If rate is increasing uniformly, if change in velocity is uniformly, means decreasing uniformly, here speed changes uniformly, but its initial velocity not equal to 0. Initial velocity not equal to 0. In those cases, what will happen? We describe the motion. We describe the motion of the body by using graphs. So, we describe the motion by using graphs. So distance time graph, speed time graph, right, in different cases. So let understand the graphs, then let us understand the key points what we have in graphical representation of motion. So read your textbook, then you are able to understand it. Thank you.